Okay, and now what I want us to do is to make another vector, which we're going to call vector 3, and we're going to again use the concatenate or the C with the parentheses. All right, and this vector goes from 1 to 10, basically. The reason why we're going to do this is I want to show you what happens if you try to combine two vectors that do not have the same length. So our vector 1, you remember, and we can just print this one. All right, we'll go ahead and print both. So vector 3, 1 to 10, and vector 1 has 5 values. So when we use rbind, which remember is going to be combining each of the vectors by their rows, and we can make a new matrix with that. If we print this new matrix, what you'll see is that vector 3 goes from 1 to 10, but since vector 1 is smaller, we basically have a repeat where it fills in the additional spaces by just repeating the numbers in the first vector. So that's something important to keep in mind. Make sure that if you're going to be making a matrix by combining vectors, that you either don't care if they repeat or that they're the same length. And you can use again that subset, using the square brackets in order to change the length if you needed of one of the matrices or vectors. All right. And yeah, square brackets is what you use if you need to make a subset. So that's how R interprets square brackets. Okay, now let's make another vector, which we will call vector 4. And this vector, because again, if we use vector 3, then it would overwrite this vector, which is fine, and we're not going to use it again, but just for the sake of it, let's call it vector 4. So this one will be made up of character data. So we're going to do the days of the week. And remember, since this is character data, we are using the air quotation, or the quotation marks. And now let's go ahead and print our vector. Right, perfect. So we get all those character values. And now let's make a data frame using these vectors, which 1 and 2 should both be numeric, but 4 has the character data. And now if we print it, we can see that unlike the matrix, which only had numeric data, we now have our new DF data frame, which combines both numeric and character data. And a nice little command is is.data.frame, and that will actually let you check if you made or have a data frame. And this was the variable that I used when I made the data frame. So that's why I'm calling it DF. You could have called it data frame or, your name and then data set. It's all the same. So now that we understand the basic building blocks used in RStudio and R, let's actually work with some data sets. So there are data sets that are available. They're built into R, so we can actually check out what those data sets look like. So we're going to use the function library. Library basically calls the location where this data set or this collection of data sets is stored, and then we print the data so that we can look at it. So there's really so many different sets of data that you can use and you can explore. There's some about the body temperature of beavers and speed and stopping of cars. There's really some very cool ones in here. So I want you guys to look through this during the week whenever we have some time off between the days. So let's go ahead. We're going to work with a data set that's called Iris. It's all about different petal and flower characteristics. So you'll remember that class, right, is going to tell us what the data structure is for whatever the variable is that we're calling. And then if we use str, basically we can get additional characteristics that tell us the variable names and also like the number of observations. Okay, let's see. So one of the best functions is view, actually. So when we run view and we include in the parentheses the name of the data set that we're wanting to look at, it actually pops up in a new window. So we can actually just kind of glance over and see everything that's there. So you'll see that there are 4 vectors that have numeric data. So these are talking about the petal length, and this is, I think, the stem length and width, and then the type of iris species. So this would be a character vector. And this whole thing, as we saw when we ran class, is a data frame, right? Because we're combining numeric and character vectors. So we can basically just look to see, what are the characteristics of the data set. So these are variables shown here. This tells us what type of data, numeric, and then the factor is basically referring to there's different levels within the character data set. But really, we just want to start kind of plotting this data and be able to look at it. So just like we did before, basically we're going to create a variable. So this is the way that I wanted to call them because it is easiest for me. So I'm basically just using whatever the variable is that is in the data set, and then whether it's length or width. Remember, we use our arrow in order to define, and then the $sign in R basically means like interact with or call according to. So basically when we say in the dataset iris, I want you to look according to the species variable. And then again in the dataset iris, I want to be looking at the vector sepal length and so forth. And so the cool thing whenever you actually type this out is that once you put the $sign, it will pop up the different variable options. So that's really handy. So when we go and think about plotting, basically, there are a couple of useful tools that I think we'll go over just very briefly. So when we're plotting in R, if we use the built-in tools, we can actually just use plot. And then the structure for plotting or for generating graphs is going to be, you need to identify the data that R should be using, and then X and Y variables that you want to plot. And so if we want to do a line or a scatter plot, we can just use this plot parentheses and then these 3 different components. We can also add titles, which I'll show you in RStudio, and we can even add color as well. So when we're making a line plot, like I showed before, we're going to have, data will be iris, and then we will pick some of those variables to plot on the X and Y axis. So as an example, you could generate a line or a scatter plot with the petal width and the petal length being your 2 X and Y variables. We can also use a box plot, which this is a great way to kind of understand how evenly distributed a data set is. It will tell you the mean, the mode, how where the general range of the data falls, as well as if there's any outliers. And for that, instead of plot, you write box plot. And then we also have histograms and bar plots. So these are, going to be showing you the frequency or the number of observations for a particular variable. And so for those, here at the bottom, you can see bar plot is how we write that, and then hista would be for histogram. And for this, you can either, use a variable that you define, or you can directly just use the $sign, which means interact with or call, and then the variable name instead. And so we'll show both of those options when we get back into RStudio. And so then I'll also show you how you can save these plots. Okay, so let's go ahead and go back into R. Okay, so if you decided that you like these variable names, you can just use them. If not, create your own. And feel free to do other, or like to plot other variables other than the ones that we're just doing right here. But this is just kind of to get you, working with the data. So we're not going to use this right here, but this is just for your reference in the future so that you remember, how the format for each one of these plots is structured. So first, let's make a scatter plot. So we're going to call iris as our data, and then for this one, I'm just going to do petal length and petal width. And then if we were to just run this, okay, what you see is basically we get our scatter plot, right? We have the petal width and then the petal length. And when we want to add a title, basically, in addition to the basic structure up here, we use this command called ylab and xlab. And so this will label the y-axis and this will label the x-axis. And sometimes I like to click return basically so that it's not a very long string of text, but it doesn't matter. You can have it all on one line in RStudio, or you can hit return or enter in order to get it onto the next line. Just make sure that you have a comma so that R knows you're continuing the command basically, and then make sure that you have the proper annotation. So you want to always make sure that if you open parentheses that you have a closing parentheses, and same thing with these quotations. So when we run it now, basically what we'll see if we highlight it is that we get petal length and then petal width. And so that's now changed because we wrote these titles right here, which is pretty cool. So we can also make a line plot. So if we identify type and then we use basically the letter L, then that's one way that you can generate a line plot. And so I want to show you this because it's pretty weird looking, right? So obviously there are different types of line plots that you can generate, but I think this is a good example just so that you don't get in the mindset that just because you can make a plot that it's a good plot of the data or a good graph of the data. So, this it doesn't really help us understand the data very much, and it's not very useful. So just be careful and make sure that you think about how you want to represent the data. So again, let's make a box plot, and I'm just going to keep using this same length, and then this time I'm going to change it for species. So here I've now separated each of the different iris species, and then we're plotting on the y-axis the length of the flower. So box plots are really useful again for distributions. So now if we want to make a histogram plot, again, just follow the same general format. Once you have made some of these plots, it's pretty repetitive in terms of like the general format, which is great. You can generate a lot of different types of plots pretty quickly using the same type of data. And so let's say, and then here is bar plot as well. So we would just replace hista with bar plot. So let's together add in a color. So for the color, this is what's going to fill in the bars or the lines. So we can actually use fill as well for a bar plot. Oops. But let's stick with color right now. So fill or color will work. But and let's go ahead and try blue. All right, and again, we want to make sure we're closing it with the end parentheses. And so now we've just colored the whole plot blue. And I included in the PowerPoint a couple of links. There's some really cool different color schemes and ways that you can change the color in plots, as well as adding legends. So that's really what our main kind of take home exercise is going to be is play around with the, data sets that are in R, play around with plotting different things, think about what kind of information each plot will show you and whether or not it's useful, and then we'll come back on day 2 and learn how to do some more advanced plotting. That's it. Thanks.